All right. So today's is on implicit differentiation, but before we start that, does anybody have any questions from yesterday's work they want me to go over on chain rule? Like maybe you got stuck on something in the homework, I don't know what. All right, you guys are your usual vocal self. Okay, so implicit differentiation. I guess we'll start off with the fact that you probably don't really know what implicit is referring to. Let's talk about an explicit equation. An explicit equation is an equation that is solved for one variable. Doesn't matter what variable it is. It's just solved for one variable. So we're most used to y equals. So this would be considered an explicit equation because it's solved for one variable. So an implicit equation is one that is not solved for one variable. So a common style equation that you're probably used to is an equation for a circle. So like x squared plus y squared equals 25 would be an equation of a circle of radius 5 centered at 0, 0. And I know you didn't do much with these. It used to be part of pre-calc. I don't think you really run into conic sections much at all anymore. Is that correct? Did you guys go over circles, ellipses last year? Okay. Well, let's work with this circle. So let me graph it to start with. So the main difference is that traditionally I'll screw this up if I do talk at the same time. Okay, so traditionally implicit equations are not functions. They don't have to be. So we could rearrange a straight line so that it says like 2x plus 3y equals 10. So that's still a straight line and that's a function. But generally, we like to write equations in function notation. So if something's in function notation, then it's automatically a function because it's solved for a variable. We are going to normally write equations that are not functions in implicit form. Generally just because frequently they can't be solved for a letter easily. And so if that's the case, well, that actually makes our derivative process different. because what I can't do is I can't say find the slope of the function at x equals 3. Because if I ask you to find the slope at x equals 3, well, there are two locations on this circle that would have a slope. And that's the whole point of our derivatives, right? So what you're generally going to have to do is finding a derivative on implicit derivative or slope when we're going to be finding the slope of an implicit equation that's not a function. You're traditionally going to need an x and a y value. Now, it's absolutely possible you're going to have an equation that's, that you don't need both an x and y value. That doesn't matter. You'll always be given enough information to be able to find what you need. So let's go over the actual derivative process, though. So you'll generally be given directions something like this, where it will say find dy dx. It won't say find f prime of x, because f prime of x is going to be function notation. And so that's part of the reason why calc has all sorts of different notations that mean the same thing. Its equations can be written lots of ways. So it'll generally say find dy dx, and this is the same thing as f prime or slope. So what you're going to do is you usually will write notation around the whole equation with d dx. And that's going to be the notation that says you're taking the derivative. And what you're going to do is you're going to be taking the derivative of each term. Now the derivative of a constant, that's one of the normal properties, that's 0. The derivative of x squared is absolutely something we've done a lot of. That's 2x. What we haven't done is taken the derivative with respect to x of a different variable. And that's where this is going to be different. So if it's the same variable, that's not really an issue. Derivative with respect to x, taking the derivative of an x, is normal. What you're going to do if you take the derivative of a different variable is you start off by doing the normal derivative. So the derivative of something squared would be 2 times that something. But at the end of it, this is technically considered like a composite function for derivatives. The way you can view it is the y is in place of an x. And so it's going to be composite function methods. So if we are doing the derivative of composite functions, at the very end, we would take the derivative of what was plugged in. So this would be the derivative of y. So we would put dy dx. Now, I know the composite function stuff might confuse you. Here's probably just the simplest method for you to remember. because we were taking derivative with respect to x to start with, if you take derivative of something that's not an x, then you're going to put this at the end of it. I mean, like, if that's easier for you to remember, just do it that way. If the whole composite function chain rule thing kind of throws you off for now. This is the main difference on implicit differentiation than when we did normal derivatives. Now, we're not done with the problem because the whole goal was to solve or find dy dx. So currently, our problem says 2x plus 2y dy dx equals 0. And so I'm going to rearrange the equation to solve for dy dx. So I'm going to subtract 2x. And then I'm going to divide by this 2y because it's currently being multiplied. And then this would solve for dy dx. Negative 2x over 2y reduces to negative x over y. So this derivative that we just found would tell us the slope at any point on that circle. But you would have to put in an x and a y value. How'd this go? I mean, obviously we're going to do as many as we can today. We're going to go straight through the hour, I'm sure, because I'll want to give you as many examples as possible. But the big thing for you guys is that you understand the layout or the setup of the problem. They're different. D over dx is like a verb. It's you telling that you're taking the derivative. It's like you writing that you're taking action by doing something. Dy dx specifically means the slope because it's the change in y's over the change in x's. So dy dx is like the answer. D dx is the verb saying what you're doing, I guess. Yeah, the notations absolutely are very close, but they mean different things. And I'm not super worried about that right now if you guys write something slightly off, because that's definitely something you get used to as we keep doing them. Should I put a little harder one up? We'll go one step harder. I don't think I want to make giant leaps in difficulty today, unless you guys feel like this is going great, and then I'll make huge leaps. Why don't I put one up, and why don't you guys see if you can do this one, or get as far as you can. So it'll be the same goal, find dy dx. I'll just give you a slightly bigger equation. So this would be an equation of an ellipse. Basically, the x's and y's are not perfectly balanced, and so it would be a circle with disproportionate proportions. So it would end up being an ellipse. But it's the same setup as a circle. I will slowly start the beginnings of the problem. If you guys, if you're getting stuck, then you can kind of check where you're at. And to be honest, if you make an error, it's most likely on that first step. So it'd probably be a good plan for you to check that you did the first step correctly for the derivative process. And absolutely ask a question if you're not sure why. I have one of those 4 or 5 answers. I guess we'll call it 5. But if you have a question, I'm assuming it's actually probably on this last one, the 8 dy dx. You could. It wouldn't help, but you could. Because if you factored an 8 out, it would only be out of these 2 terms. But yeah, I mean, you could. So our goal is going to be to solve for dy dx. So what you're going to want to do is keep both of these terms on the left-hand side. Move the 2 terms that aren't a dy dx to the other. And you can do it in 1 step or 2. It doesn't really matter. So you were kind of close on the process. If you're trying to solve for dy dx, then at the end of the problem, that means there's only one of them. Currently, there's 2 dy dx's. So the easiest way to make 1 dy dx instead of the 2 that are currently there is to factor out dy dx from both of them. It's okay if they both have an 8. I mean, like, you certainly could factor an 8. It just doesn't help anything to solving the problem. I mean, it would be correct, just doesn't do anything. And then your last step is to divide by this whole parentheses. I'm running out of space, so I'm not going to write that work in. And now that I write it, I see they're all even, so from that. So the plus 4 that was right there, I would, oh, go ahead. Yeah, it's, yes, a super common mistake is to forget to take the derivative of 12 and then just to write 12. It's really easy to forget the derivative. Got it. Yeah, it's not a 4 until you take derivatives. Yep. How are we feeling on that final answer? I wish there was a feature that would, like, I know on WebEx it like lets you raise your hand. I'm kind of curious how many people actually got this one right on their own. Like, if this one went good and you got the final answer on your own, that's great. This has all of the parts that you'll usually run into. I have used the question and answer button. Actually, I don't know if it. Let's just test it because I don't know if it. I don't know if it assigns names to it. If it assigns names, I don't like that. Ask a question. Did you get this right? I should say correct, I guess. But I think you have to. Oh, you guys can even make questions? Look at that. I'm going to trash your question, Carson. Huh. I didn't realize anybody could do it. Oh, I see. You just give it a like or a... Okay. So it's not really a yes or no. It's just you hit a like, you hit the thumbs up button if you got it correct, I guess. All right. Interesting. Okay, well, let me put up a harder one. Seeing that these are taking longer than I was thinking, because, I mean, like, I didn't know how long it was going to go online. So this one is asking for a specific slope. So you're going to have to find dy dx first, and then plug in 1, 2 at the end. Now, I'm going to, I just want you guys to try the first step, because I don't want you to get too far without, if you made a mistake. So basically just see if you can get the first step correct, the derivative. Because on this one, that's where the mistakes are made. Okay, if you got that parentheses correct, I would say fantastic job. Because traditionally the first time that I put this question up, most people overlook that portion. You'll notice that I did the work for the product rule for this one. And that's because we're trying to take the derivative of x squared times y. So because you have variables being multiplied, and we're trying to take the derivative of multiple variables being multiplied, we have to use the product rule. And it's not like it's a big product rule, it's just the fact that it's different variables, so it feels weird. Especially g prime. The derivative of y is going to be 1 dy dx. Does anybody want me to help you go over any parts of this step? Because the rest of the problem is semi-straightforward, but this step with the parentheses is where majority of the brain power goes into. It's not outside. It's just the way the derivative of 4x is 4. I only put a parenthesis here because there's a minus sign. So I had 4 derivatives. Derivative of 4x is 4 minus the derivative of x squared y is the parentheses. The derivative of y cubed is this third arrow, and then the derivative of 10 is the fourth arrow. So the parentheses were only there because I knew I was going to have a plus sign, and the minus sign here means I'm going to have to distribute out that minus sign to both of them. But yeah, otherwise, I mean, like the 4 is outside of it because it's not part of that second term. Good question. It will be d over dy at some point. More commonly, it's going to be d over dt. So what's going to happen soon is this is leading to the next unit. It might even be this unit. I'll check. Might be this unit. No, it's unit 4. So we're going to essentially do like story problems. So it's easier to relate for a lot of people because then you kind of actually see how we use some of the derivatives. And virtually everything that you record or do experiments with is in terms of time. Like think of Newton with the apple dropping, right? Position, velocity, acceleration. Those are all per second squared. So we're actually going to do derivative with respect to time for a lot of things. For right now, it's just x just to be consistent. But there probably are times where we want to know how fast something changes horizontally instead of vertically. So then it would be dx, dy, and correct. We're basically just doing d dx for right now so that you don't get completely thrown off. Okay, so we're trying to solve for dy dx. So any term that has dy dx, I will keep on the left-hand side. So negative x squared dy dx plus 3y squared, and I could certainly reverse those so that it's not a negative first. I personally don't care, but I know textbooks and multiple choice answers generally reverse them. So the 2xy I would bring over, and then the 4 I would bring over. And then I'm going to factor out dy dx, so there would be just one of them. And then this is where I'll reverse these because I'm positive that's how you would see an answer written. And these answers usually come out pretty horrible. I mean, they're traditionally going to come out like that. Now, I know I went faster at the end here. Theoretically, that's supposed to be the part you're really good at already because it's just algebra, like adding, subtracting, factoring out. But I'll gladly help you on those steps too. I wasn't going to explain every detail, but I certainly can explain the details if you want me to go over parts of what's left. Your goal is to solve for dy dx. So the big idea is to put all the dy dx's together, everything else on the other side, factor out a dy dx, so there's a single one of them, and then divide by the remainder. I haven't called on anybody yet. I'm trying to think who I haven't called on for a while. Melanie? I haven't called on you for a long time. How come I am not done with the problem? Thoughts? That's perfect. Good memory. So It's really easy to get to the end of a calc problem and forget to finish it because you're so used to, like, you put so much brain power into like doing all this work that you kind of forget what you're supposed to do. So our goal was to find dy dx. I'll show you the notation AP uses. They put a line at the end of it, and then they put the info where you're plugging in at. So this is kind of the notation that AP uses a lot of times. I haven't seen this notation for Khan Academy. So 2 times 1 times 2 minus 4 over 3 times 1 squared minus 1 squared. Oh, 3 times 2 squared minus 1 squared. So 4 minus 4 is 0, so I don't even care what the bottom is. It's 0. That was an awful lot of work to get a slope of 0. Honestly, I don't even know who I haven't called on for a while. David, I don't think I've called on you for a while. What does a slope of 0 mean? What would that look like? David, do you have a mic? Or if not, you could type it in too, or maybe stuff's just not working for you. Or I can just throw it open for anybody. So I originally told you guys this equation was for an ellipse. Yeah, it is 0. What does the slope of 0 stand for? So if I have an ellipse and I have a slope of 0, where is that on the ellipse? That's what I was hoping you could. Yeah, yep. So a slope of 0 would be flat. So on an ellipse, well, it's at the point 1, 2, David. I mean, I get what you're trying to say. Our ellipse isn't centered at 0, 0. So apparently our ellipse is centered at x equals 1. Because a slope of 0 would mean that's the top or the bottom of the ellipse. If we got divided by 0, that would tell me that the slope was on the sides. That would be an undefined slope. So that would tell me it's straight up and down on the sides of the ellipse. Now, you don't have to know that this is an ellipse. I'm not even trying to I'm not trying to say you should be able to look at that and say it's an ellipse. Oh, we're not on the ellipse problem. I thought we were doing the ellipse problem still. That's awesome. I think this one's a hyperbola. Okay, well, we'll just pretend that if this was an ellipse, that 0 would be the top or bottom. How did this go? Do you guys want me to go over any part of this? Was this just too much? Do you want me to just give you one to see if you can do the whole thing beginning and end? Give you like 5-10 minutes or something? I don't know how long it's going to take. I certainly can. This is everything we're doing today. It's just this one topic. It's just these problems are so slow that, they take a while. So find dy dx at the point 2, 1. Okay, so we're sticking with easy numbers here. And it is from x cubed y, which I have no idea what this is going to look like, plus y squared minus x squared. This is probably also a hyperbola. See if you can find the slope at that spot. Maybe I should write the first step up there to make sure you guys had the first step correct. Okay. So I put the whole thing up there, and I put numbers next to each line. So if you have a question, I thought maybe that would be easier for you to ask which line. It sounds like, yeah, go ahead. Um, Honestly, if it's on a test, you're, I don't even know if you can write that on the computer. So, like the last test, we just, oh, you know what? I corrected those already. I forgot to open that up. Um, I'll double check on that. I don't think everybody's taken it yet. But I did get them corrected for you at least. Overall, it was pretty good. But going from your question, I don't even know if you'll be able to use that notation on the test because I don't know if you can put that on the keyboard. So There's lots of correct ways to write things. I was only writing it that way to show you how AP would write it. Because when we start doing some AP questions and you're looking at their answer keys, that's usually how they notate it. There's lots of correct notations. I mean, you don't have to write everything exactly like I do. Basically, if I can tell what you're doing, that's mainly the thing. Okay, I had some more examples, but I don't know if it would be overkill. They're basically the same. This last one that I put up here, this is pretty much as hard as you get. This is as hard as you're going to run into. So if you have a problem that has multiple variables and has product rule or quotient rule within it, because you could get quotient rule too, you're probably not going to get quotient rule though, because quotient rule within one of these problems would make it really difficult to solve for dy dx. So this is probably about as difficult as you'll run into. Yeah, Caden, go ahead. Are you talking about right here? I did the product rule on x cubed y. So the product rule would have f g prime plus g f prime. Wait, did I write that backwards? Oh, I wrote f prime g. But yeah, this is the product rule. So that's why over here I didn't take the derivative, but I did the derivative of y. I did the derivative of x cubed, but I did not do the derivative of y. It's just, you're going to have to be able to recognize that when you have multiplication of variables, that you have to do product rule. Okay, I think I'll be done here because at this point on, I would, I honestly, I think it would probably be beneficial for you to start practicing some of these. So why don't you guys get started on the homework in Khan Academy? I was super happy to see how far some people were already in the homework. Because this is just going to be a busy week. The good news for you guys is that, we're basically learning new topics, I think, through tomorrow. I can't remember if Thursday was a new topic as well. But basically Thursday and Friday for sure is they kind of throw a bunch of topics together at the same time. And it's not learning new topics, it's just being able to do them simultaneously. Like doing chain rule and implicit differentiation within the same problem. So it's just combining different things we're learning. So it's new topics yesterday, today, and tomorrow for sure. And then it's kind of a combination of things later. So it's not going to be, solid, like throw everything at you all at once in a week. All right. Either way, I'm done.